If you shoot yourself with a gun, you can create a copy of yourself who will continue to live in a parallel dimension. This is what quantum physics says anyway, but in reality, you would simply end your life with a rather silly death for the simple reason that quantum laws do not work in the macrocosm, and vice versa. So this, in turn, has created a huge gap in modern science for the last 100 years. On the one hand, there's quantum mechanics explaining the world of elementary particles, and on the other, a general theory of relativity that provides answers at the level of stars, galaxies, and the universe. But in order to reconcile these two areas, scientists had to put forward a completely crazy idea, according to which our universe has not 3 or even 4 dimensions, but as many as 10. What does a 10-dimensional universe look like? What happens in each dimension? And why don't we see them? Let's skip the usual and rather boring 3 spatial dimensions, the temporal 4th dimension, and immediately proceed to the 5th. If we could perceive the 5th dimension, we would see a new parallel world, significantly different from ours. This world exists in the same position as the entire universe, and also shares its origin with our world, that is, the Big Bang. We would have the opportunity to observe both worlds, to compare and measure their properties. In the 6th dimension, we would be able to see all possible universes, as well as all variants of the past, future, and present. Any of us could easily travel through time and choose the options of the future that seemed most attractive. Starting with the 7th dimension, universes with new physical laws of nature, gravity, and light will be revealed to us. If in previous cases all parallel worlds had the same beginning as our universe, that is, the Big Bang, starting from the 7th dimension, the new dimensions have completely different origins. The 8th dimension will allow us to see all the options of the past, future, and present for all infinitely emerging universes. In the 9th dimension, we would be able to compare the histories of all probable universes that originated under all possible laws of physics and initial conditions. The 10th dimension offers absolutely everything. The universal laws of physics for all universes and unlimited possibilities for movement in space and time would be revealed to man. There may also be an 11th dimension, similar in its properties to the 10th. Any further dimensions will fall back to the 10th or 11th. So this leads to a completely logical question. Since there are so many dimensions in our universe, why don't we see them? Imagine that you are a squirrel living on an infinitely long tree. In this case, you have 2 dimensions, along the tree and around it. But then you wanted an adventure, and you jumped onto a thinner neighboring tree. After that, the measurement around the tree becomes so small that you simply don't notice it and are now moving only along. The same thing happens with extra spaces. Each time you make some kind of hand movements, you cross all 6 dimensions. Only they are completely invisible, since they are compactified. This means that measurements are curled to subatomic sizes and hidden in our universe. To collapse at least 2 dimensions, we take some 2-dimensional figure. For example, the geometric shape torus, a shape which can be seen by example in a swim ring or an inner tube. This figure is defined by 2 opposing circles. One of them goes around a hole in the center, and the second goes through it. First, the torus shrinks its donut shape down smaller and then into a 0-dimensional point. When additional measurements are collapsed to a single point, their size is no more than 3.937 times 10 to the minus 34 inches, or 10 to the minus 33 centimeters. No devices exist that can visually detect anything with such an incredibly small size. 6 invisible dimensions add up to a geometric space called the Calabi-Yau manifold. But unlike the torus, the 6-dimensional Calabi-Yau has up to 500 holes and innumerable multi-dimensional circles. Power electromagnetic fluxes pass through the holes, each of which is able to be in 10 different states. American physicist Joseph Polchinski performed calculations with these numbers and found that the number of varieties of the Calabi-Yau is approximately 10 to the 500th power. The size of each circle of a Calabi-Yau manifold is called a module. Such modules are fields in 4-dimensional spacetime and correspond to the size of the Calabi-Yau manifold. At the same time, these points are the so-called scalar fields, each of which determines such values as temperature or atmospheric pressure. Relatively speaking, when we look at indicators about tomorrow's weather, we're actually capturing signals from all hidden spatial dimensions. However, there is another way to see the manifestation of each dimension in our world. According to string theory, which gave rise to the idea of 10 dimensions, our entire universe consists of the smallest oscillating strings, too small to be detected with any device. Their vibration is determined by what kind of particle is involved. In one dimension, the string vibrates in such a way that we can see a photon. In another dimension, vibrations occur completely differently, which allows us to detect an electron. And so, with all particles, each is the embodiment of its dimension. If you follow this logic, you are also a 10-dimensional creature, since you consist of almost all the supposed elementary particles. The presence of a large number of measurements allows scientists to explain many phenomena. For example, why gravity is so weak. Indeed, of all physical forces, gravity is the easiest to overcome. You do this every day constantly by raising your legs while walking. In turn, the electromagnetic force is 10 duodecillions, or 10 to the 40th power times stronger than gravity. This should not be so, but string theory explains these differences with the fact that they have different strings. Gravity has closed strings, allowing you to move into other dimensions, thereby scattering your energy. The remaining physical forces consist of open strings. Therefore, they are completely concentrated in the dimensions accessible to the human eye. Although it is possible that the measurements are even greater. Since string theory also has its mathematical inaccuracies, scientists proposed a theory of superstrings involving as many as 26 dimensions. According to this theory, besides strings, the universe is also made up of brains, multi-dimensional analogs of strings in the form of plates, smaller in size than the point in space in which they are located. According to Souvik Banerjee, our universe is one of these brains, which is an expanding bubble, inside which there are other dimensions. The ends of the strings from additional dimensions go out into our universe, thanks to which we can see all the existing substances. Actually, to prove this crazy theory, one of the most expensive projects in the history of mankind was built, costing about $10 billion, the Large Hadron Collider. This giant device was supposed to fix the lack of gravity in the collision of elementary particles. The higher the collision energy, the higher the probability that gravitons, particles responsible for gravity, will leave our brain and slip into another dimension. However, gravitons turned out to be so elusive that no detector is capable of seeing them. Although this doesn't mean that the high cost did not result in some success. With the help of the Large Hadron Collider, it was possible to identify another particle that can shed light on many dark spots in the history of the universe. But that is a topic for another issue. Nevertheless, this main scientific debate stands a chance of being resolved thanks to particle accelerators of the future. then perhaps the existence of strings will be confirmed, which would offer an explanation for almost every phenomenon in the universe. In the opposite case, the mysteries will only increase. So, do you think that strings really exist, or is this all a big mistake? And would you like to experience the capabilities of all 10 dimensions? Please leave your answers in the comments below. If you like the video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't done so already, and click on the bell to receive notifications of new, interesting, and fascinating videos that are waiting for you ahead.